Today I'm showing off this OpenGL demo involving a directional light that casts shadows and then other point lights that are colored in the scene. So as you can see, if we fly out, we have this floor and 10 cubes in the sky. There are also 4 colored cubes which are emitting a source of light. So this one's the yellow cube and it's spreading this yellow light. We have this red cube which is putting a red light. We have a white light, and then we have a green light back here. And then we can see there's also a generic skylight that's casting down in this direction and casting a bunch of shadows on the floor. So if we explain how this works, we have down here, we have 3 different shaders. We have our regular shader, our light shader, and then our directional shadow shader. So for our shadow shader, it's pretty simple. We just take in a light space matrix and a model, and then we just do nothing in the fragment shader since we don't draw it. The light shader uses this vertex shader, which takes in projection view model and then light space matrix, and then outputs these 4: a text chord, a normal frag chord, and a light space frag pause, and then it simply just draws a light using light color. Then this fragment shader, it takes in a material, a directional light, a point light, and a spotlight. It actually takes in 4 point lights. And then in our main function here, we start with the directional light, we add the 4 point lights, and then we add the spotlight and we return the value. And these 3 are similar from an earlier video if you've seen it, or if you were following Learn OpenGL's tutorial from the very end of the lighting section. This is calc dir light, calc point light, and calc spotlight, and they use all the same equations besides for the modified halfway dir. And then in dir light, we also calculate a shadow value and then multiply diffuse and specular by it. And we get the shadow value up here doing this. And in essence, what this does is when we look in the main file, we draw a separate scene, or we draw the scene to a separate frame buffer, then we save that to a texture, and that texture is what the dir shadow was drawing, and we compare the depth values of both of them. And if the shadow scene has something in front of where we're trying to render in our scene, then we'll cast it into shadow. So if something's blocking the sun's light, it will cast a shadow. And simple in concept, but it's a little more complex with the math and the code. And then in our main file, we create a depth map FBO and a depth map for the shadow. And then down here, we draw the scene once using our dir shader, and this is from up in the sky, or it's an orthographic camera, and it's from up in the sky looking at the center and facing up. And then we draw the scene again just using our regular shader and from the perspective of our camera, like this. And then down here we have render scene, render lights, render cube, and render floor. You can take a deeper look at them if you want. So here's floor, here's cube, here's render lights, and here's render scene. They're fairly simple. They're just, I turned them into functions so that they're not all in the main file. And then down here we calculate all the lighting stuff, and that's how it works. So you can see now we have a scene, we render all this in, and the cubes cast a shadow for the directional light. And I didn't quite get to finish all the stuff I wanted to do on this, so next week I'll probably be uploading an update to this, because I wanted to have all the point lights also cast shadows. And if you want to see how that would have worked, and will work next week hopefully, you should click on this video here where I do the exact same thing but with 1 point light inside a enclosed 3D scene. Until next time, see ya!